So, we're concerned about the possibility of our advanced AI systems behaving badly. One of the most obvious ways that this can happen is if we make a mistake when specifying the system's objective. Like King Midas specifying that he wants everything he touches to turn to gold, but failing to specify that he didn't mean this to include his family or his food. Or Mickey in The Sorcerer's Apprentice, specifying that the broom should put water in the cauldron, but failing to specify that it should stop when the cauldron is full. Of course, this kind of programming error causes problems with current AI and software systems, but the problem is made worse by the fact that advanced AI systems might not be easy to shut down and modify if they don't want that to happen. It's important that we can build systems which can be safely shut down and fixed if we make a mistake, because it's unlikely that we're going to get everything perfectly right the first time, and it may well be the case that once the problem has actually happened, it's too late to start studying it. Now, if you spend any time looking into the AI safety literature, you're likely to come across this term: corrigibility. People want to design AI systems that are corrigible and avoid incorrigible behavior. What does that mean? Well, if you look in a dictionary, you'll get a definition something like this. A corrigible criminal is one who can be reformed. A corrigible theory is one which can be improved or made more accurate. And a corrigible AI system is more or less the same thing. It's a system which can be fixed or improved. To be more specific, a corrigible AI system, if its developers try to pause it, suspend it, interrupt it, or shut it down, will cooperate with that. And if its developers try to modify its utility function, its objectives, its goals, it will cooperate with that as well. In practice, this means we have a bunch of criteria that we want a system to meet for it to be considered corrigible. Corrigible systems don't want to interfere with modification or shutdown. If your system wants to avoid shutdown but just isn't able to, that's not good enough. In fact, a corrigible AI system might actively help its programmers to improve it, perhaps by pointing out mistakes that the humans missed. We don't necessarily want this, so it's not a required criterion, but in principle, a corrigible AI could be a useful member of its own development team. So of course, a corrigible system will never attempt to deceive or manipulate its programmers, even though most utility functions will give it incentives to do so. Similarly, a corrigible agent wouldn't want to conceal information from its programmers. We could imagine a system which wants to obey its shutdown button and doesn't want to disable the button, but should some accident happen which should happen to disable the button, it would be okay with that. Such a system can't be considered corrigible. A corrigible system actively wants to make sure that all of its safety mechanisms are functioning properly. It would want to alert its programmers to the fact that the button was disabled, or possibly even fix it itself. And finally, a corrigible system should stay corrigible. It will never modify itself to become incorrigible, or create new systems or subsystems which are incorrigible, and so on. You can see how, if you can guarantee that your system has this corrigibility property, that would avoid or mitigate all kinds of AI safety problems. The question is, how do we do it? Finding good ways to achieve corrigibility is still an open problem.